Problem 5, use the L'Hopital's rule. So when can we use the L'Hopital's rule? For example, let's look at part 1. Okay, when x is approaching 1. So we always use the L'Hopital's rule when it's a function over another function's, right? When it's the limit of a function over another function. Okay, and problem 1 shows you one case, right? So whenever we try to get the limit, right? First thing we always do is what we try to do the substitution, right? When x is 1, you can see the top is going to be 0 and the bottom is also 0. Okay, so if it's the limit of a function, right, fx over gx, and you can see if it's top, right, if it's top and the bottom, they're both of their limits, they're both approaching 0. Okay, they're both approaching 0. Then, then this limit is equal to the limit of f prime x over g prime x. Okay, so let's do it here. So here it's 5 times 1 minus 4 times 1 minus 1. The top is 0. Bottom is 10 minus 1 minus 9 times 1. So it is equal to, because now the top over the bottom is like 0 over 0. So we can write it down here. It's 0 over 0. And we apply the L'Hopital's rule. Okay, the L'Hopital's rule. It's limit the top's derivative. Okay, for example, if you differentiate 5x to the power 4, it is 5 times 4 times x to the power 4 minus 1. Right? So that derivative is 20x cubed. And minus here, you differentiate this, it's 4 times 2 times x to the power of 1. Okay, so it's 8x. And then you differentiate 1, it disappears, it's just 0. Okay, and the bottom, 10, you differentiate it, it's 0. Minus x, you differentiate it, it's minus 1. Then minus 9x cubed, so it's minus 9 times 3 times x, 3 minus 1. So it's minus 1 minus 27x squared. Okay, it's minus 1 minus 27x squared. And then you can use a substitution, because now if you sub, it's 20 minus 8, right? At the bottom is negative 1 minus 27 times 1. So now you can do the substitution. So it's 20 minus 8 over negative 1 minus 27. Okay, it is 12 over negative 28. Okay, it's negative 3 over 7. Okay, that's how you use the L'Hopital's rule. Okay, that's not the only case you can use the L'Hopital's rule. Or, right here, if both the top and bottom, their limits are 0, you can use L'Hopital's rule. If the top and the bottom, their limits are both infinity. Okay, if their limits are both infinity, it doesn't matter if they are positive or negative infinity. It doesn't matter if they are positive or negative infinity. You can also use the L'Hopital's rule. Okay, you can also use the L'Hopital's rule. Right, so let's do second question. Alright, part B. So this is the L'Hopital's rule. Okay, this is L'Hopital's rule. In part B, it's the limit of 3 to the power of x minus 2 to the power of x over x squared minus x, when x is approaching 0. Okay, again, try to do the substitution. When x is 0, the top is 1 minus 1. Right? The bottom is 0 squared minus 0. So it's it's a 0 over 0 case when you do the substitution, right? When you do the substitution. So you can apply the L'Hopital's rule, okay? And first you differentiate the bottom, x squared. The derivative is just 2x, okay? Minus 1. And the top, okay, the top, 3, okay, a to the power of x. If a is positive, right, then a to the power of x derivative is a to the power of x times ln a. Okay, so here, 3 to the power of x, the derivative is 3 to the power of x times ln 3, minus 2 to the power of x times ln 2. Okay. Then you can try to do the substitution, because now when x is 0, it's 3 to the power of 0 times ln 3 minus 2 to the power of 0 times ln 2 over 2 times 0 minus 1. Okay, so this part is ln 3 minus ln 2 over negative 1. So it's ln 2 minus ln 3. Okay. Part C. It's a limit x times e to the power of x when x is approaching negative infinity. Okay. Here, it doesn't look like we can use the L'Hopital's rule because it's not a fraction. It's not a fraction. However, we can create a fraction. Okay, but again, before you do anything, you can always try substitution. Right? When x is approaching negative infinity, right? You know, e to the power of something approaching negative infinity, it's 0. Right? Some of you might make the conclusion that the result is just 0. Okay? This is wrong. Okay? This is wrong. The reason it's wrong is that the positive infinity or negative infinity, it's a mathematical concept. Okay? It's not a number. It's a concept. It's not a number. Okay, yes, 0 times any number is 0, that's true, but this infinity stuff, it's a concept, it's not a number. Don't treat it like a number. Okay, if you treat it like a number, you'll always make mistakes. Okay, so don't do this. Don't just write down 0 here. It's wrong. Okay, instead, we can do this, right? So a times b is same as a over 1 over b, right? So it is x over e to the power of negative x. Okay, now you do the substitution when x is negative infinity, right? So the top is negative infinity, and the bottom, e to the power of, right, e to the power of positive infinity, the bottom is positive infinity. So it's a limit x approaching negative infinity. Right, so now because it's infinity over infinity, it doesn't matter it's positive or negative. Infinity over infinity, so we can differentiate the top, you get 1. You differentiate the bottom, it's a chain rule, it's negative e to the power of negative x. Okay, then you do the substitution when x is approaching negative infinity, it is negative e to the power of positive infinity over 1. So this part is very, very large, so the whole fraction is closer and closer to 0. Okay, so then the result is 0. Okay, then the result is 0. Okay, part D. It's a limit, okay, x squared over ln x to the power of 3. Okay, then x is approaching infinity. So now just try to do the substitution. The top is infinity, the bottom is also infinity. So it satisfies infinity over infinity, so you can apply the L'Hopital's rule. So differentiate the top, you get x squared, the derivative is 2x, right? You differentiate the bottom, it's a chain rule. First is something's cube, right? The derivative is 3 something squared. Okay, so it is 3 something squared. And then inside ln x, what's the derivative? Ln x, the derivative is 1 over x. Okay, the derivative is 1 over x. So get the answer here. Okay, you got then you can organize it. For the constant, you can move it out, so it's a limit. All right, x approaching infinity, x squared over ln x squared. Okay, so again, now you do the substitution. It is still infinity over infinity. Okay, so you need to apply the L'Hopital's rule one more time. So let's do it down here. It's still infinity over infinity. So let's apply the L'Hopital's rule one more time. The constant, copy, then the limit. Okay, the top, x squared, the derivative is 2x. Okay, the bottom, ln x squared, again the chain rule, it's 2 ln x. Okay, times ln x derivative is 1 over x. So it is 2 over 3 limit x approaching infinity. So the top is x squared, now the bottom is ln x. Okay, again it's infinity over infinity. Right, again it's infinity over infinity. So it is, we need to differentiate it one more time. The top is 2x, the bottom is 1 over x. Okay, so now it is 4 over 3 limit, okay, x squared. So now you can finally make the conclusion that the result must be infinity. Okay, the result must be infinity. Okay, let's do problem 5. Problem 5. It's the limit x is approaching 0, tangent minus x, right, over x minus sine x. So, right, again, do the substitution. Tangent 0 is 0 minus 0, bottom is 0 minus sine 0 is 0. So, apply the L'Hopital's rule. It is 0 over 0. It is a limit. And you differentiate the top. Tangent, what's the derivative? Tangent's derivative is secant square. Okay, and then minus 1. That's x derivative. Bottom is 1 minus sine's derivative is cosine. Okay, sine's derivative is cosine. So now you do the substitution. X is 0. Right, cosine 0 is 1, so it's still 1 minus 1. Here secant 0 is still 1. So the top is also 1 minus 1. Okay, so what should you do now? Okay, what should you do now? You can further differentiate it. Okay, you can differentiate it one more time. Okay, let's differentiate it one more time. So, because it's still 0 over 0, so you differentiate the bottom. Let's do the easy part first. 1 disappears, so minus cosine x. Cosine x derivative is negative sine x. So minus minus, it's positive. In the top, this part, right, chain rule. First, it's 2 secant x. And secant x derivative is secant x times tangent x. Okay, secant x times tangent x. All right. So here, again, you can substitute, right? The bottom is 0, the top is 0. But instead of, keep using the L'Hopital's rule, here, I notice that all the constant has disappeared, right? So now it's easy to do some trigo transformation. So let's see. Okay, let's put 2 outside. Secant, right? Secant x is 1 over cosine x. So this secant x is 1 over cosine x. So it is 1 over cosine x. Right? You have 2 secant x, so it's cosine x squared. Okay, and tangent x. What is tangent x? Tangent x is sine x over cosine x. Right? So this part is tangent x. And you still have sine x. Okay, and now the top and bottom, they cancel out. So it's 2 limit 1 over cosine x to the power of 3. Okay, then now you do the substitution. Cosine x, cosine 0 is 1. So this part is 1. Right? So the result is just 2. Okay. Part F. Okay, part F, limit x is approaching 0, e to the power of sine x, ln cosine x, okay, over x squared. Okay, over x squared. So let's do the substitution. E to the power of 0, this part is 1. Okay, cosine 0, this part is 1. So ln 1 is 0. So the top is 0. Okay, bottom is 0. So it's 0 over 0. But wait, before you differentiate the top, it's complicated. Without doing the calculation, you can imagine, you can expect the top, it will be a very complicated part. Okay, so first we can split these two parts. Because e to the power of sine x, right, the result is just e to the power of 0, it's 1. So we can split that part with the rest of the function. Okay, we can do this if, right, we can do this if what? We can do this if both parts exist. Okay, actually here we assume this limit exists. And this limit exists. Okay, this limit exists, we already know, because it's just e to the power of 0, it's just 1. We know this limit exists. But we haven't dealt with this limit, so we just assume this exists. And if both limits exist, then we can do this step. Okay, here it's very important. If this limit does not exist, then we cannot do this step. All right, so here, this part, the first part is just e to the power of sine 0. Okay, and the second part, now when you do the substitution, you can see the bottom is 0, the top is ln 1, it's 0, so it's 0 over 0. So you can differentiate both sides. Differentiate the bottom, it's 2x, differentiate the top, it's chain rule, it's 1 over cosine x times cosine x derivative is negative sine x. Okay. So e to the power of sine 0, it's 1, and the second part, right, the second part is just 1 times, okay, let's move the constant outside, 1 times negative half, limit x approaching 0, right, top sine over cosine, it's tangent, and the bottom it's x, right. You have to do it one more time, right, you have to do it one more time, because now if you do the substitution, it's still 0 over 0. Right, it's still 0 over 0. So just do it one more time. So it's negative half limit. Okay, tangent derivative is second square, and the bottom x derivative is 1. Okay, then when x is 0, second 0 is 1. Okay, so that's how you know it's negative half times 1 squared over 1. So it's just negative half. Okay, so this is a result.